Good morning, pre-calculus. We're going to start solving exponential equations today. These are going to be fairly basic, like the ones we did last year. So there's 3 steps to solving the equations. You're going to use the property of exponents because these are all going to be simple ones. We're going to get into harder ones once we start delving a little bit deeper into the math of logs. But right now it's just going to be basic. Get the same base, the same on both sides of the equation, and then if the bases are the same, then the exponents have to be equal to each other. So then we can drop our bases and solve the equation. So example number 1, I've got 2 to the x plus 1 is equal to 2 to the 9th. Well, these already have the common base for us. So if 2 to something is equal to 2 to something, those somethings have to be equal to each other. So for 1, I can drop the 2 since it's already nice and neat for me. And then I'm just solving the equation x plus 1 is equal to 9. That's a nice linear equation. I'm going to move the 1 over to their side and I get x is equal to 8. So this statement here is only true when x is equal to 8. For 2, again, they both have the same basis. Go ahead, pause your video, see if you can do this one. I feel like you can. Welcome back. They both have the same basis of 5, so then 4n plus 5 is equal to n minus 7. Just wanted to remind you, I don't have a stylus anymore because my child lost mine. I have one on order. It left Hong Kong a couple of days ago and is supposed to be here on Wednesday. So you're going to have to bear with me, hopefully through Wednesday. I may hold off on making your Friday videos to see if that thing comes in the mail. If it does, then I'll make your videos for Friday on Wednesday. All right, here we go. 4n plus 5 is equal to n minus 7. I'm going to move 1n over to the left side, and that 4n minus that n will make the left side 3n. Moving the 5 over with the negative 7. So I've got negative 7 minus 5 would be negative 12. Dividing by 3 here, 3n divided by 3 is n. Negative 12 divided by 3 is negative 4. How did you do? I think you guys did fine. All right. For 3, we're going to have to do a little bit of exponent work. So here I don't have 1 base is equal to 1 base. So I need to work on the left-hand side and make it 1 base. So I've got 3 to the k times 3 to the k plus 2. What do we do when we are multiplying like bases? Hopefully you said, I remember that from Algebra 1. When we multiply like bases, we add exponents. So this would be the same thing as 3 to the k plus k, which would be 2k. Oh, you cannot see that. I'm going to have to go to printing. That's not what I want. This is what I want. My k's. So 2k and then plus 2. And on the other side, it's just going to be 3 is equal to 5k minus 1. All right, now I've got same base is equal to same base. So then I can lose the bases and I get 2k plus 2 is equal to 5k minus 1. Moving, I'm going to go to the right with the 2k. So subtracting 2k from both sides, I got 5k minus 2k would be 3k. And I just do that to keep the number in front of k positive. You can totally go the other way with it. It's completely fine. Adding 1 to both sides to get 1 over to the left side, I get 2 plus 1 is 3. Dividing both sides here by 3, and I get k is equal to 1. Again, pause your video, see if you can do number 4. Come back if you think you got it. All right, welcome back. So here I've got 10 to the, again, I'm going to be adding my exponents. 9 minus 4 would be 5 is equal to 10. And here we're going to be adding our exponents. I got v plus 2v, that's going to be 3v. 4 minus 11 would be minus 7. Now that we've got the same bases, I've got 5 is equal to 3v minus 7. Adding 7 to both sides, 5 plus 7 is 12. Dividing by 3, I get v is equal to 4. How did you do? I bet you did just fine. All right, that's it for 1 through 4. We're going to do some that don't have a common base next.